Welcome to today's lesson on carboxylic acids. So we're working our way through all of the organic families, and we just finished the video on aldehydes and ketones. So if you haven't done those, go back and do those first. And now we're continuing on right in the very center there with carboxylic acids. Okay, so carboxylic acids are going to contain the carboxyl group. So we've seen that C double bond O before, and we called that the carbonyl group or the carbonyl group. We have also seen that OH group, which was called the hydroxyl group, and we saw that with the alcohol family. So now we're actually going to put both of those two together, and we end up with the carboxyl. So the carboxyl is actually the C double bond O and the OH. For our simple carboxylic acids, we are only going to consider that at the end of a chain. But remember, it doesn't necessarily have to be at the end of a chain, and there are much more complex organic compounds than we're going to talk about here. Because we're only dealing with it stuck at the end of the chain, again, R being the chain of carbons, then we're going to focus on the number of carbons in that main chain. That's going to give us the root to the name. And then we are going to add on the ending to that root for the name. So we're going to take off the E and leaving that AN because they're single bonds, and then we're going to add the oic acid to the end. Okay, so once again, we're following our regular naming rules, and we're looking for our main chain of carbon. How many carbons in the main chain? So this one's got 5 carbons in the main chain. Here's our functional group over at the end. We know that functional group is a carboxyl group, so that's going to make it a carboxylic acid. So again, 5 chains is pent. So with that carboxyl group, it's going to give me pentanoic acid. That's an I. Okay, so again, looking at the next molecule here, I've got 3 carbon chain. So now I'm going to have prop, and then again, I've got that same carboxyl group. So that's now going to add the ANOIC acid. Okay, following right along, how many carbons? 1, 2, 3, 4, 5. So 5 carbons again is pentanoic acid. Now, you might be saying, well, how come this one is exactly the same as this one? They are exactly the same. One is just a line structure, and one is the full structure. Again, looking at the last one, tracing out your carbons, 1, 2, 3, 4 this time. 4 carbons is bute, so it's butanoic acid. Hopefully, as we're going through these families, if you're doing them in the order that I've presented them, you're noticing that the names are really much simpler than the branch chain alkenes and alkynes that we were doing. They're simply knowing how many carbons are in the main chain and then identifying which functional group it is and changing the ending accordingly. Okay, so really the real work is memorizing what the ending is and how it compares to that functional group, so that you can identify the functional group and know how to name it, or see the name and know how to draw it with the proper functional group. Okay, so before we talk about the properties of carboxylic acids, I just want to talk a little bit about those 2 functional groups. So we've had the C double bond O, which was my aldehydes and ketones, and we said those aldehydes and ketones were partially polar. And then we had the OH from the alcohol, which we said were very polar. So guess what? When we put these 2 together and we get that carboxyl group, this is actually extremely polar. Okay, we've got both of that polarity going on from the aldehyde, from that carbonyl group, and from the hydroxyl group. So that gives me an extremely polar molecule. And when I have an extremely polar molecule, I know that those molecules are very attracted to one another, so it's going to be really hard for me to pull them apart, which is what happens when I'm boiling and melting. So because those super strong intermolecular forces, I get the highest boiling point and melting point of all of the organic families. That's really important. Okay, this is the king of the castle, so to speak. It is the highest melting and boiling point that you're going to get of all the families we are going to study. Also important to note, it's got that OH group going on, so it does allow it to hydrogen bond to itself and to water. So again, the hydrogen bonds to itself is what's creating those really strong melting points and boiling points. The fact that it does allow it to hydrogen bond to water is making it very soluble, the most soluble of the families. And important to note, just because we're talking about an acid, this is another property of carboxylic acids that helps identify them. It has a pH of less than 7. So if I tested it with litmus paper or an indicator, it would give me an acidic pH, a pH less than 7. So where do we find these in our everyday life? Lots of different places. So sweat actually contains carboxylic acids, and this is the reason that dogs can track. So any dogs that are set out there tracking humans through the woods, through wherever, they're actually scenting those carboxylic acids and tracing those particular carboxylic acids from a particular person's sweat. Lots of organic acids are carboxylic acids, so you may have heard of lactic acid and a buildup in your sore muscles, tartaric acid, ascorbic acid, acetylsalicylic acid, citric acid is on the candy. Methanoic acid is in fire ants. So again, methanoic, that's a really small one. So when you get that bite from a fire ant and it really burns, it's actually the acid that they're injecting into you. It's just formic acid or methanoic acid. And then that really pungent smell of acetic acid found in vinegar, that's ethanoic acid. So just lots of carboxylic acids in your everyday life, just kind of matching where these molecules occur and making some connections as we learn. And then, of course, I've left you with some practice.